So, regarding the problem on superposition theorem, we'll take a simple problem and try to solve this one. See, if you carefully see the problem, determine the voltage V in the figure given above using superposition theorem and verify a result using nodal analysis. So, they are asking us to determine the voltage which has been shown in the figure V. It is across your 4 ohms resistor. And they want to verify the result also. So now let us try to determine the voltage across this resistor using superposition theorem. If you want to apply superposition theorem, you know the very first two rules. The first one, the circuit is a linear circuit. Now if you carefully see that there are only linear elements, there are only resistors and sources available here. The second thing is the second rule, whether there are minimum of two sources or not. Yes, there are minimum of two sources. There is one 12 volt source and the other one is a current source of 6 amperes. So now let us apply superposition theorem and then we will verify it. So see, so determine the circuit consists of two sources. One is the voltage source of 12 volts. The other one is a current source of 6 amperes. This is of 6 amperes. Okay. Right. So what we will do is nothing but let's the voltage when two sources are acting, let it be V, and if only first source is acting, let it be V1, and if the second source is only acting, let it be V2, and so your total voltage will be equal to V1 plus V2. These are the responses when individual sources are acting alone. So first of all, let us consider only 12 volt source and let us turn off the other source. So what is other source? I am considering only this source, I am turning off the other source. This is a current source, right? So ideally for current source, the internal resistance is infinite. So what we do, we will open circuit that one. So open circuiting the 6 ampere source, how it will be? See, I have removed that one. The 6 ampere source has been removed. So this is my network now. Now, if you see this network, you can simply apply, if you want to apply nodal analysis, then it is okay. Otherwise, you can go with simple Ohm's law or a voltage division rule or whatever it might be. Okay. So now in this case, see, if you want to apply Ohm's law, it is very simple. See what is the current flowing in the circuit. It is already open circuited, right? So there is no mesh here. There is only one mesh and this is the only mesh. Okay. See what is the total voltage in this one? It is 12 volts, but total resistance is 8 and 4 are both in series. So equivalent resistance is 8 plus 4. In series resistance, R is equal to R1 plus R2, right? So in this particular one, 8 and 4 are in series. So 12 by equivalent resistance is 12. I'll get 1 ampere. So 1 ampere current is flowing in this one. So if 1 ampere current is flowing, what is the voltage drop here? V 4 into 1, I into R. So 1 into 4, it is 4 volts. So when only this source is present, when only 12 volt source is present, I'll get voltage as 4 volts. Now I'll take, so if you want to apply voltage division rule also, it is also easy. See, there is no circuit here. It is already open circuited. So only one simple circuit and both resistors are in series. You know, V1 is to V2 is equal to R1 is to R2. In this case, it is 8 is to 4, right? So what is V1 now? V1 is equal to, its share is 8, but total shares are 8 plus 4 is 12. Into what is the total voltage? 12. So it is 8 volts. Similarly, what is V2? Its share is 4 by 12 into 12. It is 4 volts. So which means that here there will be 8 volts, here there will be 4 volts. So now what I want the voltage across here. That I am treating it as V1. So V1 is equal to 4 volts. So when first source is acting, what is the voltage? It is 4 volts. Now we will consider the second source, which is 6 ampere source. Only this source is acting. I have to remove this source. So what I should do? Ideally for voltage source, the internal resistance is 0. So I should short it. So I have shorted this one here. See here. Now there is only one source and two resistors. If you can see, both are in parallel. So if I want to determine the current here, I can apply current division rule. Because resistors are in parallel, so I can apply current division rule. Or otherwise, if you want, you can apply voltage directly. VA. This is 0, this is 0, this is 0. So this is defaultly 0. This is A. This is also no problem. So how many paths are there? 3 paths are there. So VA minus 0 by 8 plus VA minus 0 by 4. See, in this path there is directly a current here which is incoming. So I will take it as minus 6 is equal to 0. So LCM is 8. I'll get VA plus 2VA minus 48 is equal to 0. So this is equal to 3VA minus 48 is equal to 0. VA is equal to 48 by 3. It is 60 volts. So now what is the voltage drop across here? This V, capital V, only second source is acting. So I'll take it as V2. It is VA minus 0. So what I'll be getting? 16 minus 0, it is 16 volts. Or otherwise you can go with current division rule. See here I have applied current division rule here. So if this is the 6 amperes current is flowing in these two, what is I1 is to I2? It is 1 by R1 is to 1 by R. If this is I1 and this is I2. So what is it in this path? What is the current? 1 by 8 is to 1 by 4, which is equal to 1 is to 2. So what is I2 now? Its share is 2, out of total shares is 3, into total current is 6. So I'll get 4 amperes. So if 4 amperes is flowing here, what is the voltage drop here? 4 into 4, 16 volts. Any of the methods you can employ. Current division, voltage division, nodal analysis, mesh analysis. So now, when first source was acting, it was 4 volts. When the second source was acting, it was 12 volts. So totally, how much it is? 4 plus 16, sorry, it was 16, right? So 20 volts is the answer. Now understood how to determine the voltages, how to determine the responses using superposition theorem. We will take one source at a time. We will determine the response. So like that for all the sources we will determine the response and then we will algebraically sum that one to obtain the total response. Okay. So now let's check whether it is true or not. To check whether that 20 volts is true or not, now let us directly take when both the sources are acting. Now this is when both the sources are acting, right? You can directly apply a nodal analysis here, right? This is my nodal analysis. So when I utilize nodal analysis, so this is 0, this is 0, this is 12 volts and this is V or V1. Since there is only one node, I'll take it as V. So how many paths are there? 3 paths are there. V minus 12 by 8 plus V minus 0 by 4. And here there is a current which is directly incoming. So I'll take it as minus 6. So if I solve, LCM is 8. If I solve this one, I'll get 3V is equal to 60. And if I solve, V is equal to 20. The same thing which we have obtained earlier. Earlier case we have got, right? We have calculated for individual sources. We have got 20 volts, right? So the same I am getting when both are simultaneously working. So hence the theorem is proved. Okay. So I hope that you have now understood how to apply superposition theorem. Superposition theorem is a very powerful tool for simplifying analysis of complex circuits. And in particularly, it is very helpful when you want to determine the contribution of individual sources. But there is a problem, it is applicable only to linear circuits. And if there are any linear circuits if there are any non-linear elements in the circuit, then this superposition theorem fails. Okay. And most of the times when the number of sources and number of elements is less, you don't need the superposition theorem. You don't want to calculate individual responses and then sum up. You can directly go with nodal or mesh analysis. It will be helpful. But if the sources are too many and if you want to determine individual contribution, then superposition theorem is better. Okay. So I hope that you are now able to describe the steps of superposition theorem and apply superposition theorem for analyzing a circuit. Okay. So try to solve this problem. See, determine the current in 1 ohm resistor using superposition theorem. So what you should do, you should first of all, how many sources are there? This is 1 source, 2 source, 3 source. I am asking to determine the current in this one, I1. Right? So when only one source, first source is acting, take it as I1. When only second source is acting, take it as I2, I3. And then you sum all these things. Okay? That will be helpful for you. Okay? So we will solve more problems in the class tomorrow and come prepared for the class. Thank you.